Myself, Coach. Today I will discuss about machine design to a second activity. In this report on investigation of gear tooth failure in a sugar mill drive using simulation and theoretical analysis. First one is introduction. Gear drives are widely used in sugar mills for transmitting the high torque from prime movers to crushing, milling and auxiliary equipments. Because of sugar mill drive operates under heavy loads, variable torque, dust, vibration and repeated loading, gear teeth can experience bending, fatigue, pitting, wear, scuffing and tool breakage. This case study investigates the representative gear tooth failures in a sugar mill drives using theoretical analysis and propose the simulation workflow. The purpose of is to identify the likely failure mechanism, estimate tooth bending and contact stresses, and determine design or maintenance measures that can reduce probability of recurrence. This is the sugar mill industry gears. This one is problem statement. The sugar mill drive gear experienced repeated tooth damages during services. The investigation considers the transmitted load of gear geometry, material properties, loading conditions, and operating environment. Second one is objective to. First one is identify the probable mode of gear tooth failures. Second one is calculate the tangential tooth load from transmitted torque. Third one is estimate tooth bending stress using Levy's form factor. Fourth one is access contact stress and identify the need of detailed contact analysis. Next one is develop a simulation workflow for the failed gear tooth. Next one is compare theoretical and simulated stress distributions. Next one is sugar mill drive operating conditions. There are conditions and effect on gear tooth. High transmitted torque, high tangential load and bending stress. Next one is variable load, fatigue damage and stress cycle. Next one is misalignment, uneven phase loading and localized contact stress. Pure lubrication, wear, scuffing and increase the temperature. Contamination, abrasive wear and surface damages. Next one is common gear failure modes. First one is bending fatigue. Next one is overload fracture, contact fatigue or pitting, scuffing, abrasive wear, misalignment related failures. From the present investigation to root, bending fatigue or overload is treated as the primary failure hypothesis. Next one is theoretical analysis. The tangential force at the pitch circle can be estimated from the formula of torque Ft is equal to 2d divided by t, where Ft is tangential force, T is torque required, and D is pitch diameter. Next one is Levy's tooth bending assessment. It is called as Levy's form factor. Levy's theories approximate the gear tooth as a cantilever beam and provide a preliminary estimate the bending stress. A simplified reaction is sigma b is equal to Ft divided by B into M into Y, where sigma B is bending stress, B is phase width, M is modal and Y is Levy's form factor for a real gear. Next one is material selection. From we have selection of material. First one is EM8 or C45 material selection is actually in medium carbon steel, and second one material is EN353 20 Mn Cr2. These are the two materials. Next one is simulation methodology. A finite element mode can be developed from actual CAD geometry. The analysis should include the tooth profile, root fillet, face width, hub and relevant shaft interface. Next one is expected emulation result. A correctly constructed model is expected to show elevated bending stress near the loaded tooth root at high contact pressure. near the active to contact region. The exact magnitude depends strongly on geometry, load, material, fillet radius, mesh quality, and boundary conditions. Next one is comparison theory and simulation, then fatigue investigation, safety and reliability, sustainability, and from we have concluded that conclusion wear to failure in a sugar mill drive can result from bending, fatigue, overload, contact fatigue, wear, poor lubrication, or misalignment. In the representative investigation present here, two-throat bending is treated as a primary failure hypothesis. Theoretical analysis gives the tangential load from transmitted torque and provide a preliminary bending stress estimate, while finite element simulation can reveal the local stress distribution and correct condition. Combining flank inspection, theoretical calculation, and simulation provides a stronger basis for identifying the future failure mechanism and selecting corrective measures. And this case study is given in the reference of V.B. Bhandari book, Design Data book, and V.B. Bhandari Designing Machine Element, and third one is ISO standards for gear mechanism books. Thank you.